Okay, we're going to look at a new lesson on arcs and sectors today, which is going to be to find the angle at the sector, the centre rather, given the area of the sector. Okay, so we've done several examples where you've been given the angle and you've been given the radius and you need to calculate the area. This question is taking a look at kind of working backwards. It's going to give you the answer, which is the area, but ask you for the angle at the centre. So let's start with a question where we've got a sector. I'm going to call the angle in there theta. So again, previously I've been given that angle, but I don't know what it is. That's what I'm looking for. I'm looking for the angle theta. I'm told that the radius is equal to 8 centimetres, and I'm also told that the area of the sector is 25 square centimetres. Okay, so the question is going to be then to find the angle theta. Okay, now what we do know is that the area of the sector is given by the angle over 360. So that's the slice of the circle, that's the bit of the circle, multiplied by pi r squared. Or pi r squared is the area of a full circle, and we've done that before. Okay, so the area of the sector, well, it's a bit of a circle, so there's a area of a circle, so there's the bit, it's the angle of 360. So we can see that that formula then will give me the area of the sector, but I already know the area of the sector is 25, so it's theta over 360 times pi r squared. Now what I can do at that point is I can bring this pi r squared down. It's multiplying this. What I can do is bring it down and divide, and now I've got area of the sector divided by pi r squared is equal to theta over 360. Now I can now use that as a starting point to find the angle at the centre given one of these examples. So that's a good starting point to remember that you can quote that to proceed. So the area of the sector over pi r squared is equal to theta over 360, and that ratio holds to be true. Okay, so now what we want to do is to calculate theta. Well, what I can do at that point is just to bring the divide by 360 up and multiply. So now what I've got then is, by bringing the divide by 360 up, multiply, I've got theta will be equal to area of the sector over pi r squared multiplied by 360. So theta is equal to area of the sector over pi r squared multiplied by 360. I know that the area of the sector is given by 25 square centimetres, so 25 over pi r squared, well, the radius is 8, so that's pi times 8 squared multiplied by 360. Now, this calculation can now be entered into the calculator. So theta is given by 25 over pi times 8 squared times 360. So just enter all that into the calculator. We'll round to one decimal place. And to one decimal place, that will give me 44.8 degrees. It's important that I mark the units, which is degrees, to show that I'm talking about the size of an angle. Okay, let's try an example 2. Okay, this time I've got a sector like so. I'm going to call the angle in here now x degrees. Okay, the radius this time is 5 centimetres, and I'm told that the area of the sector this time is 15 square centimetres. So I can pick up at this point here. So that ratio is true, which is that the area of the sector over pi r squared is equal to theta over 360. And just like in example 1, I can bring that, divide 360 up and multiply, so that I get area of the sector divided by pi r squared multiplied by 360. So I'm just going to do that again. And that will give me theta equals area of the sector over pi r squared multiplied by 360. Okay, I know that the radius is 5, I know that the area of the sector is 15, so that's then 15 over pi times 5 squared multiplied by 360, and put it into the calculator and round to 1 decimal place. Calling that theta degrees here, but let's get it right. We're calling that angle x degrees this time. Okay, and to 1 decimal place, that's 68.8 degrees. Final answer, example 3. Okay, here's the sector this time. I'm going to call the angle at the centre theta again this time. The radius is given by 10 centimetres, and I'm told that the area of the sector is 80 square centimetres. So let's pick up from that ratio, which is that the area of the sector over pi r squared is equal to the angle theta this time over 360. I'm now going to bring that, divide by 360 up and multiply. So that will give me theta equals the area of the sector over pi r squared multiplied by 360. I can now use the next line to fill in the area of the sector and write down the radius. Okay, so that will be area of a sector, which is 80 over pi times the radius squared, which is pi over pi times 10 squared multiplied by 360. Enter it all into the calculator to 1 decimal place, and that will give me 91.7 degrees. Final answer. Okay, let's try one final example. Okay, so this time I've got a sector which has got a radius of 4 centimetres. The angle at the centre, I'm going to call this time theta again. I'm told this time that the area of the sector is 15 square centimetres. Okay, so I can kick things off with that ratio, which is area of the sector over pi r squared is equal to the angle at the centre theta this time over 360. I'm now going to bring that, divide by 360 up and multiply, and that will give me theta equals area of the sector over pi r squared multiplied by 360. I know that the area of the sector is 15, and I know that the radius is 4, so let's put that in. So that will be 15 over pi times 4 squared multiplied by 360, and put it into the calculator into 1 decimal place. That will give me 107.4 degrees. Final answer.